So in this video we're going to be going through choosing your project. So we're going to be looking at what makes an appropriate project, what you can actually make, examples of what you can make, more examples of what you can have a look at others have been making, is a project of A-level standard, examples of not A-level project standards, and what could make them A-level standard projects. So in this video we're going to go over your most important choice you're going to make in your project, what you're going to actually make, and it's important we get this choice right. So the more effort you put into thinking about what you want to choose and picking something that would make you want to spend the time on it, the better you're going to do. So what makes an appropriate project? Well, as it does take a significant amount of time to complete, we're talking many hours to complete here. It will contribute to 20% of your overall A-level grade as well. And to put that into perspective, over the last couple of years, 21%. So if you were to get full marks in your exam, and then 1 mark on either of the tests, that would be enough to have a passing grade of an E. So the fact that it can just the coursework and 1 mark on a test of 200 possible marks, on 2 tests, of 200 possible marks, already getting you to 1 of the grades. You can see it can boost people up. There's less of a distance between 2 grades than 20%, so it's really worthwhile putting some effort into it. But that means that we need to choose an appropriate subject for the project. So it's got to be something that will maintain your interest over a long period of time. It's going to take you a while to do. It's not something that you're going to be able to do in a week or 2 weeks or even a month. It's going to take you from when you go and choose it to through to February time. It's got to be suitably challenging, so it's going to enable you to fulfill your potential. It's going to be challenging. Later on in the video we're going to talk about not A-level standard, and it needs to be of A-level standard, or else we're not going to be able to fulfill your learning potential and potentially not access the full mark range. Okay, so we need to choose a project that's going to be able to potentially get you the full mark range available. Whether you actually get that or not is a different matter, but we need to start off with the ability for you to achieve that. And if it's appropriate, if the teacher or your teacher can help you and assess you and support you. So it's you, the student, who is going to decide upon the project subject, but there should be some sort of dialogue and discussion between your teacher and yourself to make sure that you are ticking all of these boxes, that you can be picking something that's going to be of interest to you, you're choosing something that's challenging enough and that's complex enough or potentially complex enough to be of A-level standard, and it's something that can be supported and assessed by the teacher. Because in the end of the day, yes, we're saying that it's a learning experience, all of this. We want it to be a really good challenge for you that's going to push you and help you grow in computer science. I spoke on the last video about the students that really put a lot of effort into these projects, improving their paper 1 grades through that. We are still getting assessed on this, and it still will be 20% of your A-level. So we want to try and get the maximum amount of marks we can. And you're able to choose between a solution to a problem or an investigation. And again, we're going to explain what those are next. So a solution to a problem. It's where you select a problem and you develop a system to solve it. Okay. This one typically has a third party or somebody else that you communicate with that you're making it for. It doesn't have to be an end user. It doesn't have to be an end user for your project, for what you produce. However, it's beneficial when it comes to research and investigation that you have at least one person there that you can speak to. For some projects, it may be useful to have multiple people to talk to. We've got some examples of what a solution to a problem might be. So first of all, some sort of simulation, business or scientific in nature, or a well-known problem such as Conway's Game of Life. We've got a little animation of that in the top left, top right corner here. But do go away and see it and do a bit of research. It's a very interesting simulation based on cellular life forms, but it extends into some really interesting things, and you can see there's very interesting patterns going on now. And it only follows very basic rules. So something like that could be very good. Solution to a data processing problem for businesses like stock control or a membership system. These are typically what would have been made on the last specification or in IT qualifications. Lots of data to process and lots of rules for membership systems, who's got access to what, etc. And can we cancel memberships, start memberships, edit memberships and things. There's still a market for that. There's still a lot of people producing projects like that because they kind of have an early understanding of it already. An optimization problem, production of a rota, so staff have to work this time, this time, this time. Shortest path problems, route finding. You've got mazes I've got a maze image at the right hand side there as well. So it could be finding routes through mazes, finding shortest path on a game, production of a rota for a company that deals with a lot of staff that have holidays, that have sickness, an automatic production of a rota rather than manually doing it. A computer game with a dynamically created maze, a computer game with a pre-made maze. Probably that's kind of where we're starting to see differences in the A-level standard versus not A-level standard. Dynamically meaning that it makes it when the program's running, so it's not a pre-made maze. Expect interesting projects and interesting mazes and stuff. An application of artificial intelligence, so applying artificial intelligence to a particular problem. A control system using Arduino board, and I've got a little picture at the bottom right there what an Arduino board might look like. So making an embedded system of some sort. Maybe you're not wanting to just make some software here. You wanted to do software and hardware mixture. The Arduino board is one of a number of boards and solutions that we could use. A website with dynamic content driven by a database backend. Yeah, you could make a website. It's not one I favour particularly, but it can be done. And again, that word dynamics there, so it doesn't want static web pages, so web pages that are all the same. It wants to have dynamic ones, and it wants you to have a database in the back end. So yeah, it ends up being complex enough to be classed as A-level. An app for a mobile or a tablet, remotely control a server. These are just examples. They're not the only ones you can pick. Making a mobile app, quite tough. More tough than you might think to make something beyond just buttons that you can press, beyond a basic graphical user interface. It ends up being quite difficult. And that's solutions to a problem. The alternate that you could do is an investigation. That's where you have a particular interest in some area of computer science, and you want to investigate further into that area. So the last ones, we'll go back to the list. You were making a simulation, you were making a solution to a business problem, you were making a computer game, you were applying artificial intelligence to something, you're creating a control system or a website or a mobile app. So there was something like kind of whole being created. Your investigation might not have something whole. So it's the focus where your focus still needs to be on the programming. So we can't just do an investigation where it's all theoretical. You need to produce something in the end. But you can focus on one particular thing. So if we look at some of these examples here, 3D graphics rendering. So that could be producing a 3D scene using the programming that you've done. Does that scene have to be a full game? No. It doesn't have to be a full game. There doesn't have to be extra things attached to it. It doesn't have to be a database attached to it, like you would expect for the solution to a problem. This investigation is focused on what program or what programming am I going to do to be able to render a 3D scene. Similar with the machine learning, perhaps just making, on the last example of solutions to problems, making snake. I wouldn't advise my students to make snake, because I think there's too many tutorials out there that already have existing, this is how you make snake in C#, this is how you make snake in this and that and the other. But if you went and followed one of those tutorials and made your snake game, but that wasn't the key bit of your project, the key bit of your project was, how do I make machine learning algorithms and applying them? You could apply machine learning algorithm to this snake game, or to something like Tetris, or whatever it might be. It's more of an investigation on one particular thing, rather than trying to solve a huge problem, rather than trying to be something complete. It just tries to be focused on one particular area. Analysis of live feeds of data, like Twitter feeds. So what can you do with that? How can you analyze it? How could you visualize it? Investigations of neural nets, of a noughts and crosses player. So again, we're not talking about very complex games and stuff that we're making here. Noughts and crosses there, but with a neural net and how it's going to learn how to play. Very interesting to look at. Exploring large data sets for correlations, World Bank data sets, and visualizing what they are. So looking at huge sets of data that you can gain access to and interpreting them, investigating what programming you could do to visualize them a bit better, to create interesting questions, to find interesting patterns. And scientific investigations where an analytic solution is not possible, so you kind of have to simulate to a degree. So they're the main two sections, so solution to a problem or an investigation. I have got loads of examples for you. I've got 2 playlists of videos on YouTube. One of them's got over 120 videos of student testing. Some of them are the same students, just with multiple videos. But 120 there for you to go and look at, see example games, see example systems. And we're just seeing them from the aspect of them testing them. There's a mixed type of projects. There's all sorts of different ones there, and all sorts of different standards as well. There's 2 playlists there for you to have a little look through. I'm not suggesting you sit there and watch them all, but certainly go through. If you start to get an idea of what project you want to make, go and look at for some, see if there's some similar ones or ones with similar aspects to what you're interested in, and see their testing video to think about what yours could end up looking like. And on the VLE, there's lots of documented examples. Got loads of moderated and marked projects. So these are ones from the exam board to help us as teachers to mark your projects and to make sure that our marking is correct. And you get to see their commentaries, you get to see the marks, whether they thought it was good or bad, and take examples of what you could put into yours. And I've also got a selection of interesting past student projects that I've had. Mostly they're in there because they've got great documentation and they are good to very good marks, but I have not given you the mark in there. So yeah, on the VLE, you've got a number of folders for you: past student examples, moderated projects for the exam board, and then some more moderated ones and standardised ones in 2019 as well. My past student examples, big list of them here, could continue to grow. I'm just going to have a quick cycle through them and show you the sort of standard we're looking for. So first up, got a Guess Who game. Guess Who doesn't sound particularly complex, but when you start to think about what was included in this and what was set out to be included, you had randomly generated faces, so dynamically created game boards. It wasn't just using pre-existing pictures and things. These were all they all look brilliant, of course. They were all created when the program was running, to have different attributes with them. So you notice some have got mustaches, some have got no hair, some hair, long hair, short hair, different coloured eyes in the hair, and it's all been generated randomly. Yeah, some with hats and eye patches as well. But not only that, so there's a potential there for object-oriented programming in there. They've also got the potential for AI, and it did. It had a simple AI that you could play against, and the AI would look for the most common characteristics amongst the faces, the people, and when it got the most the ones with the most in there, it would choose to ask a question about them, whether they had glasses or no glasses. For example, here I've not counted up, but there's lots of people with the blonde long hair, so it could potentially ask a question there. It could be that the most common thing is the eye colour. A computer could do far better than I could with this. So yeah, it would make a list of all of those and then eliminate them as it went through. Not a particularly difficult game there, but some complexities to it, having that simple AI, having having object-oriented programming in there, and potentially databases. I don't think this one did have databases in the background, but definitely of high-level standard when you got into all of the objectives that were set out. Common thing of booking systems and business helping systems. You got a table booking system. Again, you just it needs to be fully well rounded. So this one had lots of dynamic buttons, and throwing people in at certain times, putting identifying the tables, and creating these buttons dynamically, depending on when people had booked a table and what table they were being put on. It was quite good. They had a database backend that included many tables, and we're able to access those through using SQL, and it all ended up being very much complex enough for an A-level project. It wasn't just table bookings in the end. They ended up going into doing the menu and taking orders as well. This one was a volumes of revolutions simulator. So it's where you could type in a function. So say y equals x squared. I think that might be this one up here. And then if you imagine that line being rotated around the x-axis, you could form some sort of cone shape. So this student did volumes of revolution as part of their A-level in maths, but found that the teacher didn't have a good way of visualizing them. So they made this system, and it looks far more impressive than what you see here. These wire meshes were made at runtime, and then you could rotate them round. So you'd be able to flip and rotate these to get a better understanding of what the volume of revolution could look like. The students was doing a tower defense game. It does not look very impressive at all. They did not concentrate on the appearance and looks, which is fine. You wouldn't get marked necessarily, depending on what the application is, but generally speaking, you're not going to get marked on appearance that much. You do want it to look good, and this one did look good in movement, in action. It was very well programmed. There was lots of incredibly complex object-oriented programming, and it worked very smoothly, even when there was lots of objects on the screen. I think they could have done a better job with the graphical aspect there, though. But it wasn't marked down for that. This one is an interesting one. This was a temperature sensor. So this is an example where somebody used one of those Arduino boards that we mentioned earlier. So they did some physical electronics on top of programming. So it was there to avoid the issue of people working at food counters where they have hot food having to take temperatures regularly and then keep going and washing their hands and writing stuff in a book which gets greasy and holds germs and etc. The idea was that you could have this one device where you just stick the temperature in, you press a button, and then it records it, and you could go through all of the products and do that, and then just plug it into a computer where it would upload those results. Very simple idea, but complexities come from using the physical hardware, programming in one language here, creating a way of getting the data to upload to his own made program here, which accesses a database at the endpoint, and it was a very good project. Somebody enjoyed his physics, made a projectile motion simulator. He made it for his physics teacher. So you see we've got a cannon here, and you can change the angle and the velocity of the cannon, press fire, and you get a visual to see with it. And you get lots of other things. It included loads more than you see here as well. It included random question generator as well, so it would ask questions in the way that the exam board, in this case his exam board for physics was OCR. OCR would ask questions, randomly generate questions. It would even make worksheets based on this topic. It was a very, very good project. This one was an example of a quiz. So quizzes often are quite common with this project, these A-level projects. They're not always able to get very good marks, and you have to be very careful about selecting them. I think we'll talk about quizzes in a few moments. But they did lots of different types of stuff going on. We've got anagrams, general knowledge, and riddles. And the anagrams one was where it was able to use a bit more programming a bit more, processing to select words from a random pot of words, determine what difficulty they would be, and mixing them up for someone to try and solve. There was lots of other things in the background here. There was lots of good statistics and leaderboard and database things in the background. So although it had a general quiz at the top, they were able to do lots with it. They were able to in program edit questions, edit riddles, add new words for the anagrams, as well as just going and solving them and taking part in these. And you can see that they did nice visuals as well, getting graphs made too. Next up, these are a few screenshots because this one didn't actually have anything visually amazing. This was an investigation into neural networks. So I've just taken a few screenshots of his documentation and his testing here. And neural networks, essentially getting the computer system to learn, to recognize patterns, and he did it using to recognize speech. It was just an incredible project, way beyond what we'd expect at A-level, really. And he would train it with his voice and different WAV files. So use WAV files to train it, and then once it was trained and it got good results majority of the time, the error reducing massively there. He then tested it with other people's voices, and all it was to do was recognize numbers. But that's what I said earlier about the investigation part. It doesn't have to do an awful lot, but it has to do something really well. So he focused on being able to decipher the WAV files and then identify what number they have said. And it worked incredibly accurately. And it only worked for numbers 0 to 9, but it could have then pushed out his program to start recognizing letters next. And it would just be a case of training it up, just a case of time. This was an interesting one. This was called Do Some Maths, and the student decided to use the Microsoft Kinect. So you see here this little frame of the body, that was captured using Microsoft Kinect. So that was pointing at somebody and then establishing nodes. Now the Microsoft Kinect did a lot of that on its own, but he had to do some of the processing involved in that, and then adapting it to his game. And it was doing some simple maths. It was getting people up and active and doing maths. So you see here the sum appears, and the font is used a weird question mark, and then stretching out on one side to the other would end up choosing that answer. So physical as well as a mental game here. Just showing you the range of things that you can do. So you can use the Kinect as well. This one was a very good one. It was a cipher tool. So this student wanted to be able to cipher and decipher an immense amount, way more than what was needed for A-level and for the project, really. A big list of potential ciphers, and not just encrypting and decrypting, but discovering what the trying to crack the code as well, using things like frequency analysis and other very very complex tools. This one, another physical one. This student again did a investigation. This time it was into computer architecture. So if you can identify some of the words there, you can see they built some sort of processor. They had a clock, they had a program counter, stepper, and also, as well as doing the physical stuff, which was immensely complicated, keeping track of all of those wires. They did have some good diagrams to make sure that they didn't go wrong there. They also made their own integrated development environment, their own assembler. Sorry, they made their own assembler to convert assembly language into machine code. I think, if I'm remembering rightly, they did follow the AQA instruction set. So it was a really interesting program there, and you can see what the outputs ended up being. It just ended up being lights, little LEDs lighting up, but it worked, and he could prove that it worked. And yeah, it wasn't a useful thing for anyone really in particular. It was his investigation. Back to more traditional problems. You can go in and solving problems like the 8 Queen problem or the Knight's Tour problem. Famous challenges that can be set, and getting a computer to challenge them using things like brute force, seeing how long it'll take to brute force the issue, and using backtracking and other complex systems. He used chess and very simple rules of chess to work out how to go about brute forcing or using backtracking algorithms, and came up with a decent project. And finally, on this little list that I'm giving you, another maze. This time the student made a dynamic maze and wanted to display lots of different ways of solving it. So they were able to dynamically create the maze and then run different solving algorithms. So you see here they ran 4 depth first searches, and they gave them left wall solve, right random wall solve, right wall solve, random wall solve. So one of them favoured picking the left wall every time, one of them favoured the right wall every time, one of them just ended up being random, and it ended up working the efficiency out based on how many cells visited versus how many cells there were to the end root. And doing things like displaying the route in the end as well, and displaying where things have come back. So this one here went that way first, found some dead ends, and made its way back. So the blue route and then the red line indicated the route to the end point, and those yellow spots indicated where it visited in addition to getting to its end point. Yeah, very interesting projects, and hopefully yours will be as well. And there are more than what I've just introduced to you there, just again to give you a little insight and a little idea of what we could make. So a really important question for us is a project available standard? And it's hard to answer, but a general rule of thumb is thinking, is it beyond GCSE? If we were to look at the computer science specification for GCSE, are we using techniques and algorithms that are at A level or above, that aren't on the GCSE spec? So if we were making a project where we just had a linear search as the most complex algorithm we're going to use, well, the linear search is on the GCSE specification. So it's not what we decipher as being available standard. We kind of have to think to ourselves, does it have the potential for? Now, it doesn't actually have to include everything, and you might make a project that is of GCSE standard, but as long as you set out where it begins as a project that could be available standard, we're not going to have any issues. So common things we can look out for: complex OOP, we saw before the guess who game, not very complex, but when you start to include the idea of dynamically creating all of these faces, having complex OOP in there, and then introducing AI, all of a sudden it becomes more complex. Databases. So again, there was the financial and business models and business control systems. Do they have a database with several interconnected tables? If you've just got the one table or the two tables or even three tables, it's not really going beyond what you'd expect at GCSE. Have we got complex user-defined functions? Do they do mathematics that's above A level or above? If they're just doing GCSE mathematics or below, it's probably going to be a no. If we're just the most complex thing in our project is going to be calculating average, it's probably not going to be something that we can say this is definitely available standard. Now, I'm not saying don't include average if you need that, but I'm saying if that's one of the most complex things you've got, the project's probably not A-level standard. Do we use, that's meant to be data, apologies, data structures like stacks, queues, trees, hash tables, dictionaries, other abstract data types that are not at GCSE, that are beyond GCSE. Networking, do you stick networking in there? And networking is complex. So you have client server, peer-to-peer, what have you got going on there? And the scientific, mathematical, robotics control business, the models that we're using, are they beyond what we'd expect at GCSE? It's a tough question, but you can always ask your teacher if you're concerned at all. And we just need to make sure that the project that you're choosing has the potential to be available standard or above, even if in the end you don't make it above that. The reasons why is if it isn't A-level standard, then all the areas that you're going to get marks are going to be moved down by 2 marking levels. Or many of the areas, sorry. So, for example, if a student gets a fully or nearly fully articulated design of a problem, they're going to be in the top mark band, level 4. So they're going to be getting a mark between 10 and 12. If they're knocked down by 2 mark bands, that's almost certainly going to be half or more of their marks lost. So if their A-level project is deemed to be not A-level standard, no matter if their design was brilliant, top band, 12 marks, they're going to have that knocked down to 6. And anywhere that a downward shift is not possible, then the lowest mark level should be awarded. So yeah, if you didn't hit the top level in the design, but you hit level 3 instead of level 4, yeah, you're going to be moved down to the lowest one. So it is important for us to get to start off with an A-level project, an A-level, potentially A-level standard project, even if what we actually produce in the end only ends up being GCSE level. We've got to start off with the idea that it's A-level standard. And this was confirmed by the examiner's report for 2019 as well. They still found that there was a collection of centres who submitted A-level standard work that wasn't, and then they got marked down significantly. So you could have students thinking, I've got 50 something marks, and then actually they get marked down to something like 14. It's a huge jump. That's an excessive jump, of course, but it can be a huge change. If you think about, we just looked at one example there with the design immediately going half marks or less, or more, sorry, being taken off. And it is so easy to have it be A-level standard. They're trying to show you that in this examiner's report. We need to have some objectives which will come in your analysis, and that are set that involve complexity required for A-level, even if the student doesn't meet it. If the student doesn't meet it in their code, yes, they might lose marks in their coding section, but they're not going to have every part of their project everywhere else moved down by 2 levels. So yeah, we need to set challenges that are the correct standard. So we need to set off with a project that has the ability, the potential to be an A-level standard project. Okay, so you as students should be encouraged to make sure that the objectives you set, which again will come later in your analysis, but we need to think about the project initially, making sure that you can kind of get an idea that they're going to be challenging. And if you do not meet those objectives, not just going and removing them, but keeping them in there, because that's what's going to keep your project available standard. Okay, now just a few more examples of projects that they could be. Noughts and crosses. Just think to yourself now, is noughts and crosses going to be of A-level standard? Well, an implementation of noughts and crosses in which the computer validates legal moves and checks for a winner is not of A-level standard. However, if there's some good implementation of artificial intelligence, then they could turn the project into one of A-level standard. The range of marks would depend on how sophisticated the algorithms for the AI was, but it could be turned into A-level standard by introducing the idea of AI. A better way of making sure that this particular project, noughts and crosses, or sorry, not this particular project, but a project chosen by this student was available standard, would be potentially to choose a more sophisticated game, one which had more rules. And we're not saying always go for chess or something of a similar difficulty, but a game where there's more potential. You know, a standard noughts and crosses, it's just 3x3. So you could choose a more sophisticated game, or make that game more sophisticated. Perhaps you could end up doing noughts and crosses 3D. If you've got a 3-dimensional noughts and crosses board, the AI that's needed would have to be more sophisticated and would definitely be of A-level standard. If you've got a 3-dimensional noughts and crosses, you could also include 3-dimensional visualization. You know, how are you going to actually visualize this 3-dimensional noughts and crosses? So yeah, using advanced graphics, or perhaps playing noughts and crosses over a network. As I mentioned before, networking can add quite a lot of complexity. It is not easy. A rota system, that was mentioned before as a good way of a good system that you could have as an A-level project. And storing information about the employee availability, the shifts that the employees are needed for, and the business need, and then matching the two together. Yeah, that could be A-level standard, but it's got to be made. You've got to make sure that it's the algorithms, the processing that you're going to do that's matching these up, not the user. If it's a system, if it is a system where it's just a manager sat there dragging employees into free spaces, and all it does is check if an employee is in there twice, in the same shift twice, it's not going to be available standard. If we could click a button and it automatically creates these shifts that the employees are doing, that is a complex system then. especially when it starts to include things and other factors taken into account like staff holidays, qualifications. Perhaps you always have to have a first aider on each shift, but there's a limited amount of first aiders. Desired working hours. Some people can have a preference as to when we should try and get them to work more than others. If it's got an algorithm with that like that, it's definitely available standard. So you tend to get these ones being made by people that have part-time jobs and have found that their shifts get given poorly, or you don't get enough information, or you keep getting the wrong shifts. They want to make a system that will help their local business. So if the matching here, if the rota was done by the user, it's unlikely that this project would be an available standard. If it was created by some processing, some data processing, then it's definitely going to be available standard. And rota systems can be quite complex. Encryption. A program demonstrating simple encryption methods such as the Caesar cipher, it's not going to be available standard. There's a limited amount of processing being done. So hopefully by me using the word processing a lot, you're hopefully seeing that that's where you're going to be getting the marks, and that's where we're saying the complexity is coming from. What you're actually processing, what you're actually doing. So limited amount of processing, so it's unlikely. It could be done, and I've seen some very good Caesar ciphers made, not as projects, but as just side programming tasks that they've done throughout the years. And you can make the Caesar cipher quite complex with multiple jumps and different types of key systems other than just the shift. But if it was just the shift cipher, there's a limited amount of processing there. But a more complete system with alternate types of ciphers, as we saw in the example of one of my past students, graphical ways of displaying the Caesar cipher wheel, so being more complex with the graphics, the ability to load and save data. It's still getting towards A-level standard now. We're saying that it's going to be A-level standard, but just on those things alone, it's not likely to achieve high marks. And remember, we want you to get the high marks. We want you to be able to achieve that. So incorporation of code cracking options, frequency analysis, comparing potential solutions, dictionary text, and cracking the codes. Cracking the codes here would make this encryption available standard for sure. And potentially, depending on the way that we crack the cipher text, potentially access to full marks. Lastly, quiz. Quiz is a common one as well. You find this being handed in every single year, some sort of quiz program. A quiz that stores multiple choice questions and answers in a single table or file and scores users based upon their answers to the question is not going to be an A-level standard. We'd expect a GCSE student to be able to do something similar to that. You notice there's no processing going on there. It's missing the key aspects for an A-level project. The additional functionality of users to log in, for their scores to be saved, and for questions to be edited within the program. So you're not just loading a file that's already been made, you're actually doing the editing in the project that you've got. That's making the system available standard. Whether it would be a particularly high level of standard is debatable, but you're starting to get to A-level standard there. The implementation of more sophisticated techniques, such as analysing responses and tailoring questions to future quizzes. So you might have done quizzes online where they aim on improving your knowledge, and when you get a question wrong, it kind of makes note of that question and has you answer it again. In fact, there's some research that says that you should answer, these quiz type things should make you answer them correctly a few times before just saying, oh no, they know how to do that. And if you're starting to get questions wrong, those ones need to come up more frequently in future tests. So techniques tailoring future quizzes based on past ability would be very good, and starting to get higher marks for technical solution for what you're actually making. And again, they've mentioned there working across a network, so having multiple people accessing the quiz at the same time. I have had somebody make a localized Kahoot, so a question and answer quiz where I have it on my computer as the teacher, as the server, and then the students have their different program as the client, and put the question on the board, and they all answer through that system. And it ended up being quite a good implementation of a quiz. So that's it. Hopefully that's given you some understanding of, or some ideas for the project you're going to create, going to choose. Make sure you go and watch those videos, see the existing ones, look at past projects, get some ideas together, and next video we'll look at how you go about approaching the project from then.